Now we're going to talk about a Poisson distribution. Poisson. I just looked it up in the dictionary. First of all, we need to define E, which is a transcendental number a lot like pi. It's going to be the limit as x approaches infinity of 1 plus 1 over x to the x. And if you do that in your calculator, you press second function, ln, which is the natural logarithm, 1, enter. You're basically taking e to the 1 power, and you're going to get 2.71828. Okay? Now, a Poisson distribution is basically a distribution that applies to occurrences over a specified interval. A lot of times we use time as that interval. And a Poisson distribution probability is defined as the mean to the x times e, our transcendental number, to the negative mean over x factorial, which kind of looks ugly, but really isn't too bad. The example we're going to use is in World War II bombs over London. London was divided into 576 regions. There are 535 bombs that hit London in World War II. We want to find the probability that of those 576 regions, we want to find the probability that one was hit exactly twice. So we have to use this formula. The mean is going to be 535 bombs in 576 regions, or we get 0.929, and that would be bombs per region. See that our mean is a little different meaning there. Mean here is 535 over 576, or 0.929 bombs per region. So now if we put it into our formula, we're going to get 0.929 to the x. We want exactly 2 bombs per region times e to the negative 0.929, the negative mean, over 2 factorial. Now I like to do these calculations separately. If I take 0.929 to the second, I'm going to get 0.863041. If I take e to the negative 0.929, again we're going to do second function ln, 1 enter, we're going to get e raised to the negative. Make sure you don't use the minus sign, use the negative 0.929, and you should get 0.394948614. And 2 factorial, we should be able to compute. That should be 2 times 1 or 2. And if I do that calculation, I get a probability of 2 bombs hitting a region is 0.170. And if I want to find out how many regions were hit exactly twice, I would take that probability times the number of regions, and I would get 97.92, or about 93 regions were hit exactly twice in World War II. One nice thing about the Poisson distribution is that if I have greater than or equal to 100 trials, and n times p is less than or equal to 10, I can use the Poisson distribution to approximate the binomial. So we're going to play the pick 3 lottery every day for 365 days. Again, pick 3, I have 3 choices, 10 for each. I have 1,000 choices. One of those is the winner. I have a 0.001 probability of winning. So, can we do this in this case? Well, 365 is bigger than 100, and if I take 365 times 1 over 1,000, I get 0.365, which is less than or equal to 10. So I can use the Poisson distribution in this case. Okay? So, the probability that I win exactly once in 365 days is the mean, 0.365, to the 1, because I'm going to win once, times e to the negative mean over 1 factorial. And I think if you do those calculations, you're going to get a probability of 0.253. So you would have a 0.253, 25%, 1 out of 4 chance of winning once in 365 days. Again, as in all gambling, the odds aren't with you.